Yeah, I'm just going to do a tutorial real quick for those people that are using Arnold, since it's such a cool render engine. The new version is pretty legit because now you can GPU render. And before, you could only CPU render. The only problem with Arnold is render's very slow, and people have hesitated using it because it takes so long to render, and everybody's kind of jumping at GPU render engines like Octane or Redshift, and there's a few others that are much faster, and they also look really good. But Arnold is probably the most photorealistic render engine that you can get for Cinema 4D. So yeah, let's build a little scene. I've got some cool little like background things. So I'm going to use this stage. You can also start with like a plane or something. Now I'm also going to put some objects in here just so we can get a good feeling for the amount of light and stuff. But in order to start to make this look cool, let's add some lights. What if we add a like an area light? I'm not sure if this translates into Arnold, but we're going to find out. Because I think this is what we normally do. Traditionally, we use an area light like this. And, you know, if you're making like a little... probably do something like this. See? And then you probably also bring another one out here into the front, or maybe like front top, something like this. Then I hold down Shift to get it to kind of snap into place. And now it's looking a lot better. This is the standard render engine, nothing fancy at all. Say we have those lights coming from each side and then one from the top. So we're building a scene here. But let's create a new material. And this material is going to be for the shapes. So I'm going to choose Beckman, roughness 20, reflection strength 50, and I'll leave the specular strength there. Now look what this is going to do to the shapes. I'm just going to drag and drop the material onto the shape. And now it's going to be a lot different, right? We're actually going to see some, you know, some reflections. Now the physical renderer looks like this, and it's got the like kind of default settings there. Look at my CPU, by the way, when I render this. All those cores spike up to 100. All right, so that's the physical, and I think they look very similar, but now let me add some things here, because when I normally do this, when we render with a normal renderer, we have to add ambient occlusion and global illumination. So I'm just going to do that so we have like a basis for comparison. And let me go ahead and save that. Now let's look at it like this. It's going to take a little bit longer to render, but now we're getting into AO. Look how it gives the tree depth, those shadows in there. It's very dark in between the leaves. It's going to be very dark along the edges of where the shapes touch the stage. And that AO really gives depth. It's very convincing. And then the global illumination is kind of some reflections. The way light bounces makes the light look more natural. So do you see how it's getting better and better as we add these things? That's normally what we would use because that comes with Cinema 4D and you already have it available. So there's no need to do anything more. The physical renderer is fine. I love it. And it's good for render farming. It's good for sharing files. If you build a scene with the physical renderer, you can send your file to somebody else or run it on another computer and it'll work. Once we go into the third-party render engine into Arnold, there's no turning back. That means we're not going to be able to share the file unless the other person has Arnold. We're not going to be able to render farm unless the render farm has it. You see what I mean? We're going into an area where the workflow, the future workflow is going to be affected. And we're going to have to make a decision. If you decide to use the third-party render engine, you got to go all in. It's all or nothing. All right, because you're going to have to switch your materials over. You're going to have to switch everything over. We're going to go to the settings, flip it over to Arnold Render. We don't need ambient occlusion and global illumination anymore. Those are going to be irrelevant. I'm just going to delete them. Arnold Render has all the GI and AO and everything built in. These are the default settings. And I'm not even going to touch these yet because we don't have to. But there are things that I like to do here. I'm going to leave it as it is, just so we don't get confused. Here's the CPU GPU setup. So I'm going to keep it on CPU. You're going to want to try GPU. I know. It tells you a little bit about compatibility. So it tells you which GPUs you can use. You can use NVIDIA's. And you also need an updated NVIDIA driver. But I'm going to stay with CPU because the GPU will kill OBS. It'll kill my recording. So I'm not even going to do that. We're just going to stay here. Okay. And I'm also going to show you how to use the denoiser. This is why you want to use this render engine. This denoiser is nuts. All the pros, like the IPR window. All right. But this is your workflow genie. But it looks like we're not ready for it yet because we need to fix our lights. See, these are area lights. So this is going to be the first of a few steps of kind of converting the scene to work with Arnold. And I'm going to add this little tag to it, which is called the Arnold parameters tag. And it automatically knows it's a light. This tag basically works for all kinds of stuff. You just use one tag and it knows what you put it on. Let me bump up the exposure just in case. It knows what the area light is. So I'm going to turn the normalize off and then just go ahead and increase the intensity till it looks like what you think it should look like. I can duplicate this object to the other lights and there it is. Now we're lit. So we got this IPR. Look how cool the IPR is. When you move around, it renders in real time. That's converting those area lights into an Arnold object. But there are Arnold lights that might be more appropriate for this. And if we wanted to do those, come in here to the Arnold plugin, and we can choose a quad light. The quad light is the same as the area light. I'll put it over here, right about where this one is. And I'm going to disable this one and just use the Arnold light. I'll disable all of them. And let's see how this Arnold light compares to the Cinema 4D area light. Very dark. If we put up the intensity and turn off the normalize like we did before, I wonder which one's going to look better. But see, the quad light has the exposure setting. So maybe that's better. I don't know. Let me duplicate the Arnold lights because I think I can do it pretty fast. But you got to turn them around because they kind of point. They're directional. And let's go back and see what it looks like. So that's what it looks like with the Arnold lights. And then let's see what it looks like with the C4D lights. I mean, can you tell the difference? I don't know if I can even tell the difference. But I'm going to use the Arnold ones because I think those are going to be proper for scene building. We can also give them colors too if you want to make it a little warmer. Warm it up a little bit. A bit warm, I'd say. I like the way that one looks. Look how it kind of reflects off of that material. And then this one here is coming in really soft. Maybe we could make it like that blue, soft blue light or something. And then let's bring them all together. I like the lights from the side without the top one. But there's other things we can do too, like we can add an Arnold sky object. So let me turn these lights off and now we just have the sky. And I think the sky is how you do your HDRI and stuff like that. We can do a physical sky, which looks like outdoors. It's going to be like a warm, distant light effect. So this is just using the HDRI sky. And you can see if you look at that, ooh, it's taking way longer to render too. I can hear my computers going crazy. But you see how the lights look like that? And I bet if we detach from the camera and we go and look around, you'll see all these lights up in the sky. And that's how it works. It's got this giant light box right there. And you can see the shadows too. So there's lights kind of coming from all directions. So it's kind of a natural HDR lighting. All right, so first the camera though, because the camera is like so key for everything. So if I click on the camera tag, it gives me some cool stuff like enable depth of field. Yes, please. Exposure settings. So you get that real physical camera look. And you could do some stuff with the aperture blades, but I'm not going to do any of that. It's not needed. Really, what I use the most is the depth of field and the aperture size. The aperture size is what's going to give it that crazy depth of field look. So let's pull in the IPR and see what that looks like. So I've got the camera here, right? And I'm going to set the focus distance. I'm clicking on the camera, set the focus distance right on the tree. Like, I don't know, we're like right there. And then I'm going to set the aperture size. And see how I increase it? It gives it that crazy depth of field look. But this part where I clicked on is going to be the point of focus. So there's like this one little focal point, and then everything in front and behind that are going to be out of focus. Maybe I'll go like 2 centimeters, which is a pretty good deal. Cool, let's render it and make it look a little bigger. So the output size is 1280 by 720. All right, I'm not going to save it like this. We're just going to render just to look at it. Okay, the render settings are pretty modest. I'm not going to be using very much volume indirect, subsurface scattering, or transmission. I'm mostly using specular, diffuse, and anti-aliasing. So these are the ones I want to focus on. All right, so this is the part where people complain about Arnold being a bit slow. You could see it's thinking really hard as it's rendering, and my CPU is going crazy. And it renders it out. But here's the thing, there's still noise on the square and on the sphere. The GI looks great, the AO is great, the depth of field, everything, perfect. But there's so much noise, like it needs more settings. It's going to take even longer to get it to render with these settings. All right, the other thing I want to do is I want to show a mesh light. I'm going to go to the Cinema 4D tags and I'm going to add a mesh light to this. Okay, so let's configure this light then. Here's the area light settings. Intensity is 4, or like almost 4. So I'll make it a little less, like 2. Turn the normalize off. Custom visible intensity. We're going to make it look like it's very, very bright, like all the way bright. And then the actual amount of light that it's putting off, we can check that. We can turn off all lights except for that light, like make it look like it's a legit street light. It's illuminating the tree. This is about to get cool, guys, because we're going to do volumetric lighting next, which is one of my favorite things in Arnold. Now I'm about to blow you up with something that's been one of my favorite Arnold features. We got to go down here to environment. And I'm going to add atmosphere volume. So we're going to do an atmospheric light. Let's bring back our IPR window. Look at this. This is where Arnold starts to get cool. So now you can just kind of let your creativity go crazy with this kind of lighting. You can create really cool effects like daytime volumetric effects that look like fog, nighttime effects. I did a Star Wars while this is rendering. Let me show you my Star Wars. See that little volumetric effect, this red light here? This is just an example of motion blur is absolutely superior. But here's a volumetric lighting effect that I was looking for that I wanted to show you. And this is Alteric Valley from World of Warcraft. And you can see BB-8 is kind of running through AV. What are they called? What are these things? What are these Star Wars things called? This one was a lot of fun. It never got finished because it was too much work. Essentially kind of bit off more than I could chew in the amount of time that I had to do this project. We learned a ton about Arnold and rendering in Arnold. And then we also put a goblin in the TIE fighter. Yeah, there's your volumetric light. So if I go to the atmosphere and we can kind of mess with the density, we can make it look even foggier or less foggy. We can change the color. You know, we can give it kind of like a blue look to get the effect you're looking for. And then if you want to make it look less grainy, you can increase the samples here, or you can just also increase the diffuse and the anti-aliasing in these settings here. So those are 2 ways to get rid of that grain. I try to keep the samples at 5 here because the render time will get really super crazy. I would probably do something like 4 and 5. This will take crazy long, but let's see. If you're just rendering like 1 frame, well, then you can just let it render. I mean, it could take 15, 20 minutes. It could take an hour if it's going to look amazing, if it's just 1 frame. But if we animate this, maybe we have hundreds of frames, and that's where you have to really optimize the settings. And I think we cleared up most of the noise, but there's still one more magic trick that I'm going to show you. It's going to reduce the render times and clean up the noise, but there's a special way we have to do it. So there's 2 ways we can do it. We can clean up the noise by just increasing the settings, which we want to try not to do. we can take the AOVs, like the individual layers, and we can clean them up in After Effects. We can denoise in a different program, which is totally possible. And then number 3 is we can just use the built-in denoising that's built into Arnold. And I think that's probably going to be one of the faster and more effective ways to do it. Okay, it's done rendering. Here's the denoising. Let's go ahead and jump straight into the denoising. Arnold has its own built-in denoiser. And what you do is you pull down this little pull down right here and you create an EXR driver. It adds the denoiser driver right here. Let's take a look at the driver and set an output. It's going to enter, the path of where it's going to be saved. It's like that. For more compression, we can use DWAB. This is OpenEXR. This is some OpenEXR theory now. There's a lot of options to save in. If you want lossless, you can use the zips or the PIZ, but we're going to make them very small. So you can use DWAB, and these are also After Effects friendly. And you can also render at half precision, which takes it from 32-bit down to 16-bit, if I understand that correctly. And it makes the file smaller, and you're not even going to notice the difference. So we're going to do that. We can't choose a file. I can just probably copy this into here, because that's where it's going to be. Made a mistake here. I got to put this in the input, and then the output automatically comes out. I'm going to bring these settings down a little bit, because those settings were kind of crazy. And let me render that. So this is going to be a noisy version, and then we'll see how well the denoiser can handle the noise. And then the very last step, I think, for this demo will be to import it into After Effects and then see what we can do with it in AE. All right, so we got our render, right? And then now we go to the denoiser. And we select that file that we just created. And by the way, that file is like 3 megabytes, not much, pretty small. It's pretty small for an EXR. EXRs can get huge. I'm just gonna use the default settings here. Auto detect threads. So it's probably gonna make my computer go crazy. And I just click denoise. It's going to start. Let's try to count. Like 1, 2, 3, 4, 5, 6, 7, 8. 8 seconds. It took 8 seconds to denoise this. If the denoise does a better job than increasing the anti-aliasing, we saved a huge amount of time, because the anti-aliasing, if we put it up like 1 or 2 more points, it took a whole extra minute or 2. And if you're working like at 1080 or 4K, 10, 20 minutes, an hour or 2 more. And that denoise just took a few seconds. So let's see what it looks like. Okay, so there's the denoise. And it looks like there is some pretty weird artifacts right there. I don't know where that's coming from. I don't know if that has something to do with the compression that I added, or if that's just a denoise artifact. But when I click through them, you should be able to see the graininess went away. But then we got banding now. But there was like this weird little artifact right there, completely went away. So it still needs some love. There's also these AOVs. So AOVs will render out every layer, the background, the direct, the indirect light. And so you can kind of dissect all of the different layers, and it will help you render, or help you composite them in After Effects. This is one that I did a little bit earlier. And so this is an example of how you can do all the different layers. See, that one right there is the emission. That's diffuse, specular. That looks cool. These look cool to toggle them on and off like this. That one is a coat, subsurface, scattering, volume, and background. There's nothing there, so some of those are empty. Let me put those back. I'm gonna make a new driver. I'm just gonna call it Psy. Direct, indirect, and emission, right? And background. Yeah, let's do those. And then you can see that it pops up right here, and I'm going to name it. It's going to be Psy output. Call it Psy. Lol. I'm again going to use the DWAB at half precision, just to keep the file sizes small. So yeah, this is weird, right? This is how Arnold works. You got to set up these AOV things. You don't have to. I mean, you can render it out the normal way, where you just save the final image like you normally do under the save area. But in fact, I'm not saving the traditional way at all. I unselected those. Here's our outputs. These are the outputs that we just rendered. There's the background, the direct, indirect, and emission. So I'm going to drag those over. and make a new scene. Right now I'm in 16 bits because 32 bits had some weird stuff. I'm also in linearized working space. These are some important settings. It just happened to work good with the EXRs. I believe these to be some solid settings. Maybe we could do better. But now we're in After Effects. Yay! So let's drag these in. First, let's take a look at the direct lighting. Ooh, that looks kind of cool. Volumetric stuff. Now we bring in, next let's bring in indirect to see the difference. There's indirect, that's the glass and the light and some of the light that it's shining onto the tree. And then let's bring in the emission. So that's the volumetric stuff. And it looks like it also has the sky because the sky is also emitting light. Oh, interesting. So what's in the background then? Nothing? Oh, shoot. I was hoping that the sky would be in the background. It's going to make this a little more difficult to denoise, but whatever. So we have all these layers, and I think what we got to do is set them to add. So they all add on each other. You see that? So we rebuilt the Beautify just with these 4 layers, well, 3 layers actually, because nothing was in the background. Direct, indirect, and emission to completely rebuild the Beautify layer. But now we have layer control, so we can edit the layers independently. And then if I toggle on the Beautify, on and off, it looks exactly the same. Let's get in there, shall we? Oh yeah. Dude, I just blew this up. It's ruined. Now it's ruined. This is like a lamp post from space. That was dumb. Now, you know we can't just stop there. We got to do more lens flares, right? We got more. I mean, we are compositing, so, you know, why stop there? Let's composite some more. Right? We go through all that problem to denoise. We hate noise. It messes everything up. Only to add noise in compositing, right? So there's the noise effect. Well, we're not going to use that much, but you do, in fact, want to not have it so smooth because then you get banding. You get all these weird artifacts. If you add just a little bit of noise, it helps. Sweet. So this demo is done. I'm going to close it down and then I'll make a video a little bit later.